Hey everyone, in this chapter presentation, we're going to be talking about the decreasing time algorithm, which is very similar to the priority list, except now we're going to be creating our own priority list. So the decreasing time priority list is literally just a priority list creating in decreasing time order. Decreasing means we start with the biggest and we go to the smallest. The decreasing time algorithm is just an algorithm that uses the decreasing time list to create a schedule, just like we did with priority list. So let's look at this. We have the decreasing time algorithm. We're going to prioritize the first 15 or the 15 tasks using the biggest and then to the smallest. So we're going to look at our graph, and where is the biggest number on our graph? Well, the biggest number is an 8, then we have a 7, 6, 6, 5, 5, 5, 4, 4, 3, 3, 2, and 1. We simply just list them out in the order that they are decreasing. So using the decreasing time algorithm, if we have two processors, let's say we get the schedule shown below. We assign all of these that we had right here based on, we want to do AD first, then we want AP, then IW, so forth and so on. We schedule it out. Our finishing time is 42 hours. You can see we have a little bit of idle time here, here, and here. All right, so now let's do an example ourselves. So the first thing we need to do is look at our digraph, our project digraph, and create our decreasing time priority list. So where's the biggest number on our graph? Well, we have a 7, so C is going to be first. All right, then we're going to have the next biggest number is A. Then we're going to have a B, and we have an E. So in this example, we have two 5s. B and E are both 5. So we can actually do either of them first. It really doesn't matter. It's as long as we're going to do both of them before we do the next one, which is D. So we're going to have D right here. All right, so this is now our decreasing time priority list, and we're going to treat this the same as we did the priority list. We're going to circle the ones that are eligible. We have two processors. The first one we want to do is C and then A. So the first processor is going to get C. So we're going to have 7 units of time for C. All right, we're going to start working on C. Processor 2 needs to work on something, so we want them to work on A because that comes next in our list. We're going to start working on A. A is 6 units long. All right, now we're going to move along and then we finish A. Well, we can't circle D yet, so the only thing that's left is B. So we're going to go ahead and start working on B, which is 5 units of time long. All right, now we're going to move along and we finish C. We can circle E. So we're going to write E here, which is also 5 units of time. All right, we start working on E and we move along and we finish B. When we finish B, we can now circle D because we finished A and B, and we can put D right here. D is 2 units long. We start working on D, we move along, we finish E. We can't do anything yet until we finish D and we get to our end. So our finishing time for this one is 13, and we have a little bit of idle time right here. So our idle time is only 1 unit of time, or 1 hour, whatever unit we're working with. Now let's do it again. We have two processors. We're going to create our decreasing time list, priority list. We're going to look at the biggest number in our graph. The biggest number is C. The next biggest number is an 8, which is A. Next biggest number is a 7, which is D. Then we have an E and F, which are both 6. Then we have a 5, which is B. And then we have finally G, which is 2. So now we've got our decreasing time priority list finished, and we're going to start working on the actual algorithm. So our step is going to be circle the ones that are eligible, and with two processors, the first processor needs to work on C first. So C is 9 units of time. So we're going to put C right here. Start working on C, and now processor 2 needs to work on something. We're going to work on A. So A is 8 units of time. All right, we move along until we finish A. Well, we can't move on to D yet, but we can do B. So even though it's way down here, we got to do it because it's the only thing that's left to work on. So we're going to have 5 units of time for B. We're going to move along. We started working on B. We finish C, we can circle E. Now we can start working on E. E is 6 units long. All right, and then we move along and we finish B. Now we can circle D and start working on D, which is 7 units long. So let's write D right here. All right, we keep moving along and we finish E. We can circle G, start working on G. G is 2 units. And we actually finished G before we even finished D. So we keep moving. We can't do anything here. So it's just going to be idle. We finish D. We can circle F. So we can start with F. Let's just assign it to processor 1. And F is 6 units long. So this right here is our idle time. And we started working on F. We keep going. We finish F. And then we're done. This is also idle time, so our finishing time, finishing equals 26. Our idle time, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So idle time equals 9 units of time, or 9 hours. All right, now lastly, we're going to do this other, which is very similar. This next decreasing time algorithm, we're going to create our decreasing time priority list by looking at the biggest number. So our biggest number is C. Then we have the next biggest number is 7. So we're going to have A or F. Then we're going to have D, which is 6. Then we have E, which is 5. And then we have B finally, which is 4. So now we've created our decreasing time priority list. We're going to perform it with 2 processors, circle the ones that are eligible, and we want to do C first. So C is 8. We're going to write a C right here for processor 1. All right, then we're going to do A because that's the next in our priority list. So A is 7. We're going to start right here. And we're going to move along. Now we finish A first. The only thing we can work on is B. We can't circle D yet. So we're going to have to assign B right here, which is 4. All right, we're going to move along. And then we finish C, so we can circle F. We start working on F. All right, let's move F along. And we finish B. Now that A and B are finished, we can circle D. We can start working on D. So if we work on D right here, we move along and we actually finish we worked on D, we finish F. Now we can't circle anything yet. We got to wait until we finish D. We finish D, we circle E. Now somebody can start working on E, so let's assign that to processor 1, which is 5 units of time. All right, we have a little bit of idle time here, so let's not lose that. We're going to work on E, move along, and then we finish E, and we're done right here at finish time of 22, and we have some more idle time here. So our idle time is 1, 2, 3, 4, 5, 6, 7. 7 units of time, or 7 hours. And that is decreasing time algorithm.